Hi everyone, welcome to my project management channel. I am Dr. Carlos Chavez, and last week we covered qualitative risk analysis, its inputs, tools and processes, and outputs. I am including a link to that video in the video description section just in case you want to review it before jumping into this one. Based on that video, we were able to do a quick and easy baseline risk analysis, a methodology by which we were able to do an initial risk prioritization. Now we can spend some extra time on the top priority risks and do some more detailed analysis. The detailed analysis will require more data and time. This is quantitative risk analysis. Today's video will be a bit longer as we will cover more technical material. There's a lot of analysis and there's no way I can cover it in enough detail and make it justice while keeping this video short, as I promised in the intro video. I will provide links in the video description section for additional sources. I will also do videos dedicated to the different tools in the future. For now, we will do an overview. A common denominator for all the tools we will discuss today is that they involve significantly more time in either data gathering, analysis, or both. The inputs we will need to perform quantitative risk analysis are the updated risk register that we updated last week, the risk management plan, cost and schedule information, other relevant project-related documents that impact the risks identified in the risk register, such as the procurement, quality, and HR plan, among others. Now, let's discuss some of the tools and processes commonly used in quantitative risk analysis. FMEA, or Failure Mode and Effects Analysis. This tool helps us identify and quantify potential project failure. It looks at the frequency and cost of failure occurrence, impact on project objective, severity, and likelihood of detection. Think of this as the quantifiable version of the probability and impact matrix we discussed last week. We can use some of the tools from qualitative risk analysis as input to this tool, such as expert review, lessons learned, and brainstorming to look at causes of failure. Now we can look at what we define as high impact risks and spend extra time finding the value of the failure, the true value. Likewise, we can look at what we define as high likelihood values and find the true probability of the risk. Finally, we use the values of the failure severity and multiply them by the probability of risk. Now we have a more clear priority based on further defined values of risk. PERT, Project Evaluation and Review Technique. This technique is quite useful when we can't predict durations or have a high degree of uncertainty or variation behind them. Now we rely on hard data to help us do the evaluation. This tool uses what's called a 3-point estimate, and that is the most likely, the optimistic, and pessimistic estimate. We use those three values to calculate the expected time and the standard deviation or variability of the time for accomplishing an activity. We use those values calculated through PERT to feed other tools such as critical path, fast tracking, crashing, among others. Monte Carlo simulation. This is a mathematical modeling technique that yields a performance forecast range based on presenting different scenarios and their respective probabilities. This is done by building models of possible results by substituting a range of values based on some sort of probability distribution for any uncertain value. The computer simulation runs a determined number of times, as defined by the user, and gives the user an estimated value based on the probability distribution. The more simulation runs, the lower the error, but also the longer it's going to take. I could do a video just on Monte Carlo simulation, and I will. In fact, there are courses just in this tool. My PhD dissertation was a mathematical model. But at this point, I just want to give you an overview. Expected monetary value, or EMV. This tool uses a combination of statistics and the cost management plan, along with data on possible monetary impacts of risks and opportunities. It calculates the average financial impacts for different scenarios. The tool is relatively simple to use. Multiply the value of each outcome by the probability of occurrence. Then add the values in a series of events in each scenario. Sensitivity analysis. It helps us assess the impact that different levels of uncertainty have with respect to the project objectives. It works by looking at different scenarios within each target output variable and the impact created by each input variable. This is a different version of simulation and is a way to predict the outcome of a decision given a certain range of variables. It helps the project team understand the effect of independent variables on a dependent variable under different conditions. For instance, if you remember last week, we covered the effect of rain, dependent variable, on pouring foundation schedule, dependent variable. And we studied a range of times, 3 hours, 3 days, and 3 weeks. Cost-benefit analysis. This is a tool through which the project team and leadership team can decide on action, risk mitigation, elimination, or acceptance strategy by identifying the benefits of it and subtracting the cost. Generally, the option with the greatest overall value is selected. Critical chain project management, developed by Dr. Goldratt in the 1990s, is a scheduled network analysis technique that looks at the precedence network, critical path, resource availability, and schedule buffers to complete the project in the shortest amount of time possible. Critical chain project management looks at the precedence network and loads resource tasks. The output is the critical chain for the project. That is the schedule network that takes into account task dependencies and resource constraints. Buffers refer to any available slack on tasks that don't impact the scheduled delivery. Tasks that are not in the critical path, by definition, contain some buffer. Buffer is typically added to the critical path at the end of the project. We'll make a video just on CCPM and theory of constraints. This is one of my favorite project management methodologies. Alternatives analysis. It refers to the evaluation of choices available to complete project goals, objectives, and deliverables. As it applies to risk management, this methodology is a comparison of risks, opportunities, risk responses, costs, team and organizational capability in response to risks and opportunities. A typical output or deliverable from alternative analysis is a recommendation on an alternative over the others and showing why it is better than the others. The audience is typically decision makers such as the project manager, sponsors, the change review board, or other relevant stakeholders. Contingency response strategies and planning. Contingency plans describe the actions to be taken if a specific risk or opportunity occurs. This involves what do you do as the likelihood or impact of a risk increases over time? What are the risk responses under different scenarios of a sensitivity analysis? Is there pre-approval by the change board on the scope, schedule, or budget as a result of the risk presentation? What is the communication plan on the risk? Again, these are some of the tools and processes through which we can do quantitative risk analysis. The output of this analysis is the updated risk register with the results of the analysis. Now let's look at some examples of quantitative risk analysis in real life. For this week's example, we are going to build on last week's example of qualitative risk analysis, and now we're going to perform further analysis of it using quantitative risk analysis tools. The input is the risk register updates that we made last week that now include the risk values for risk 1, 2, 3 and opportunity 1, 2, 4. The tools we will use this week are sensitivity analysis, EMV, and alternative analysis. For our sensitivity analysis, we were going to look at risk 1, 2, 3. In this sensitivity, we will look at what is the schedule on the equipment manufacturing plant in reality. So we determined 3 different scenarios after coordinating with the equipment manufacturer. Scenario 1, the RFP arrives as scheduled. In that case, the equipment manufacturing process is going to be 2 weeks late. The impact is 2 weeks worth of deliveries and late fees on POs on our end for a total of $4,000. The probability of this happening is 80%. Scenario number 2, RFP arrives in 3 days. In that case, the equipment manufacturing process is going to be 1 week late. The impact of that is 1 week worth of deliveries and late fees on POs for a $2,000 cost. The probability of that happening is 70%. For scenario number 3, the RFP arrives in 1 day, next day. In that case, the equipment manufacturing process is actually going to be 1 week early. The impact of that 1 week is going to be early delivery. It frees up capacity to expedite shipping and benefits in cash flow for $1,000. The probability of that happening is 70%. Now let's look at the sensitivity analysis for our opportunity 1, 2, 4. Under scenario number 1, the RFP arrives as scheduled. The impact is no additional cost. This was already built in the plan. The probability of that happening is 95%. Scenario number 2, the RFP arrives in 3 days. The impact is the additional cost on procurement and administrative teams for overtime and inefficiencies in expediting process is $300. The probability of that is 60%. Under scenario number 3, the RFP arrives in 1 day, next day delivery. The impact is additional costs on procurement and admin teams for OT and inefficiencies. The total cost is $500. The probability of that is 60%. Now with this information, we can feed some of our further analysis tools. Now we're going to use EMV, decision tree, and alternative analysis. Now we have a decision to make. Do we expedite the RFP, yes or no? In the case that we don't, we move on to scenario number 1. In that case, the opportunity has no cost. However, the cost of the RFP arriving on time is a cost of $4,000 at an 80% probability. If we do decide to expedite the RFP process, now we have another decision to make. By how much? If we get to the manufacturer in 3 days, then we looked at scenario number 2, which the opportunity has a cost of $300 with a 60% probability. The cost now comes down to $2,000 with a 70% probability. If we expedite to the next day, we move on to scenario number 3, where we have a cost of $500 with a 60% probability for the opportunity. And now what would have been our cost and our risk becomes an opportunity of $1,000 with a 70% probability. So now that's our decision tree. So we can look at the different alternatives and do a full EMV. So we know that we have a value, an impact, and a probability. We multiply them by each other, and now we have the full cost of the scenario. In the case of scenario number 1, we have a cost of $3,200. For scenario number 2, we have a cost of $1,580. In scenario number 3, we have an opportunity of $1,000. This information can now be used by the decision makers, and by presenting the alternative analysis, we can easily justify scenario number 3 as the preferred choice. Finally, some classroom problems on quantitative risk analysis. They're going to look very similar to the ones we covered last week. What is the purpose of quantitative risk analysis? We want to know that you understand why we use these more involved tools. What are differences and similarities between the different processes and tools for quantitative risk analysis? In this case, we want to know when to use one versus the other, or like in the example that we just discussed, when to use multiple tools. And finally, what are some suggested modifications to the risk register as a result of quantitative risk analysis? Thank you for watching today's video on quantitative risk analysis. I hope this was useful. Stay tuned for next week's video where we will cover risk responses, monitoring, and control. If you enjoyed today's lesson, don't forget to hit the like button and subscribe to this channel for future videos.